Welcome to 9-6. We're continuing on with quadratic equations, and in this lesson we'll be learning how to analyze solutions to quadratic equations, and in particular we'll be looking at finding out the value of the discriminant. The discriminant is b squared minus 4ac. This is the term that's underneath the radical in the quadratic formula. Remember, we had x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Well, this b squared minus 4ac, that's the discriminant. You'll notice there is no radical here in the big idea section. So even though it is under the radical in the formula, the discriminant itself is simply b squared minus 4ac. Okay, with that we can tell whether we have 0, 1, or 2 real solutions. Let's take a look at how this works out. We'll go through some examples to get us ready. Example 1, a firefighter, well, you can read this, shoots a flare, path of the flare is given. Now this is a path quadratic, not a time quadratic. So this is a distance and height calculation. Okay, so x is distance that it's traveled outward. Well, it's 60 feet up. So it started up where this was 60. And it somehow went up and out. So from an axis standpoint, this is our y-axis, this is our x-axis, and so we have some initial height where it started on the y-axis when x was 0, at 0, 0, or at 0, and then we head on out from there. Okay, so here's our question. Graph and generate a table of the parabola with the equation to answer the following questions. Will the flare ever reach a height of 90 feet? Will the flare ever reach a height of 100 feet? And will the flare ever reach a height of 110 feet? Okay, well, the first thing we want is our calculator. Let's get this up. We're going to make a graph, and f of x is equal to a negative 2.5 times x squared plus 20 times x plus 60. Graph it. Clearly we have to go up a ways. We know we started at 60 feet and then went up above that. So I want to go up above 60, and I'm being asked if I can hit 110. I'm going to use that to help me with my window. I'm not sure how far out I'm going to go. I'm assuming I'm going to go pretty far out in the x direction. So I'm just going to start with negative 1. Well, I'm going to go with 0. For x minimum. X max, for right now, I'm going to make that 100. Y minimum, I'd like to see the x-axis, just for yucks. So I'm going to put in negative 1 for y minimum, and y max I'm going to put in, well, 115. And I can see I got the x-axis way too far out. So we'll bring that in. And make x max 10. Okay, a little better. I could have come in not quite so far, but I can see the top of the curve. I can see my starting point, which is 60. I know that from the equation. Will the flare ever reach a height of 90 feet? Well, the first thing I want to do then is, if I look at the graph, I'm going to put in a function, and that function is going to be 90, and enter, and I can see that yes, it will indeed. And if I wanted to know where, I can find that out by using my intercept graphing. But right now I've been asked, will it ever hit? And the answer is yes, it'll do it twice. It'll go there 2 times. Will it ever reach 100 feet? I'm guessing it probably will, but let's take a look. Graph entry edit, function 100. And it looks like it does. Let's do a quick intercept analyze. Graph, intersection, oh, it asked me to point out which graphs I wanted since I had a couple of them there. And indeed, I see there is an intersection at 4,100 is the intersection, and that's only one. So at 100, there's only one, so I can guess at 110, I'm probably not going to have any, but let's try it real quick. Function, 110, and enter. And heck, I can't see it. Adjust my window. Max 120. Okay, now I can see it. Yes, and I can see that indeed there are no solutions. So for A, the answer is 2 times. For B, the answer is 1 time. For C, the answer is 0 times. Well, now that we've done that, let's take a look at this next question, which is use the quadratic formula to find the solutions to the equation presented in the previous example. Will the flare ever reach a height? So we know the answer to all of these, but what we're being asked to do is to use the quadratic to figure these out. And the expression we used was a negative 2.5x squared plus 20x plus 60. And that equals our y value, our height. So now that I have that, I can go in and look for some solutions. So at 90 feet, the expression we get for at 90 feet is that 90 equals a negative 2.5x squared plus 20x plus 60. Now, to use the quadratic formula, this has to be set equal to 0, so I need to subtract 90 from both sides of the equation. And now I have what I need to solve the problem. So I get the opposite of 20 plus or minus the square root of 20 squared minus 4 times a negative 2.5 times a negative 30 all over 2 times a negative 2.5. Okay. So let's see what we've we've got for our calculation, we have a negative 20, and 2.2 times 2.5 is 5, right? So that's a negative 20 over 5, plus or minus the square root of 400, negative, 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 so that's going to be negative. And this is all over 5, so 5 goes into, that's a negative 5, okay, right? Negative, negative. So double negative is a positive. 5 goes into 20 4 times. 4 plus or minus 400 minus 300 is 100. The square root of 100 is 10. 5 goes into 10 twice. So what we get for this is that our value is 4 plus or minus 2, which tells us we have 2 events. It's at 2 and at 6 feet out that we have this crossing the 90 feet mark. Okay? So we've distilled this down, we've got our answer. We can do the same for the other 2 results. What I'm going to do is simplify this a little bit. Yeah, maybe not. This might be a mistake. Okay. Tell you what, go ahead and make a record of this. Make sure you've got it written down, because I'm going to erase it and after I get done with our next problem. Okay? Okay, so this next one is 100, and again we have this 100 equals a negative 2.5 x squared plus 20x plus 60, and that gets us to, if I subtract 100, so I'm going to get a negative 40 here. So I'm going to end up with a negative 2.5 x squared plus 20x minus 40. And my leading term, my b term, nothing has, the only one that's changed is the c value. So I will have still this negative 20 over a negative 5, which is 4. Plus or minus, and this is going to be the square root of 400, that's 20 squared, minus 4 times a times c. And that, the only difference we had here is we've added another 10 to it, basically. Minus 4 times a negative 2.5 times a negative 40. And 4 times a negative 2.5 equals 10. 10 times 40 is 100. A negative, negative, negative is a negative. And we get, this is all over 5. And that brings us down to 4 plus or minus the square root of 400 minus 400 is 0. And so plus or minus nothing, so that it's simply, the answer is 4. There is one solution. That's just 4. Now if we look at our next value, before I eliminate this, the discriminant, remember we described that earlier, is the b squared minus 4ac part of the quadratic formula. In the first example, part A, for 90 feet, we had a positive term underneath the radical, and we ended up with two solutions. For B, we ended up with 0 under the radical, which led to plus or minus 0 is one solution. The only solution was 4, and we saw that from our graph. And let's take a look at 110 feet. And we know what happened here is there were no solutions. So what's that going to look like when we solve this? So 110 equals a negative 2.5 x squared plus 20x plus 60. So 110 from 60 will be a negative 50. So 0 equals a negative 2.5 x squared plus 20x minus 50. We can plug this into the quadratic formula, and that's an x. We have, again, our leading term is 4. Remember, we're negative 20 over negative 5 is 4. Plus or minus the square root of b squared, which is 400, minus 4 times a negative 2.5 times a negative 50. All of that over 5. Well, 4 times 2.5 times 50, well, we know that 4 times 2.5 is 10. 10 times 50 is 500. So this becomes 4 plus or minus the square root of 400 minus 500 all over 5. This creates a negative number. It's 4 plus or minus 4 plus or minus the square root of a negative 100 divided by 5. Well, the negative root is not a real number. This is what we would call an imaginary number. In a later course, we'll learn how to address this, but for now we would say there are no real solutions because we don't have a way to deal with this. And what we saw in our graph was that indeed it did not cross the graph at that point. The line we drew didn't cross the graph, so there were what we would call no real roots to a height of 110. Okay, well, let's move on to our next example. But first, a little discussion. We just saw in looking at this that the value of b squared minus 4ac discriminates among the various possible real number solutions to a specific quadratic equation. It is called the discriminant of the equation ax squared plus bx plus c equals 0. It remains true that it has to be set equal to 0. If it is not, this does not work. Stated below are the specific properties of the discriminant. So if it's true that ax squared plus bx plus c equals 0, and a, b, and c are real numbers, and a does not equal 0, then when b squared minus 4ac is greater than 0, the equation has exactly two real solutions. When b squared minus 4ac equals 0, the equation has exactly one real solution. When b squared minus 4ac is less than 0, the equation has no real solutions. This is it in graphical form. Shows us how this might appear when we graph this out for the values of b squared minus 4ac. When it equals 25, in this particular case we have two real solutions. We can see it crosses the x-axis twice. In this next function we can see it has one real solution. And in the last one, no real solutions to the equation. So it doesn't cross the appropriate axis at all. All right. One last little bit. How many times does the graph of y equals 3x squared minus 12x plus 12 intersect the x-axis? Well, at the point of intersection of the x-axis, this is when y equals 0. Remember, we'll have our axes. The origin is 0, 0. And so any point on the x-axis, y equals 0. Any point on the y-axis, x equals 0. Right? So if I want to know where it crosses, what I'm looking for is when 0 equals 3x squared minus 12x plus 12. And what we've just learned about the discriminant is we don't need to do the whole calculation to determine this. We just need b squared minus 4ac. If we have that, then we can answer this question. So let's take a look at it. So b squared would be a negative 12 squared minus 4 times 3 times 12. Yep. So 12 squared is what? You know this, right? Yeah? 144. Minus 4 times 3 is 12, and 12 times 12 is 144. So the discriminant equals 0. That tells us there is one real solution. Okay, that's it for the discriminant. Remember that when you are writing the discriminant, when you're writing it out, it's simply b squared minus 4ac, but the original equation has to have been set equal to 0 for it to apply. If it hasn't, then you, as we did for our examples, you'll have to manipulate it to get it to be 0. Okay, good luck on the mastery quiz. See you in class. Bring your questions.